Hello, this is a question about the velocity time graph from the practice exam 2019. And an engineer measures the velocity of a remote control car and he collects the data. And this is what you see according to his observation. So, first of all, I will give you the fundamental concept that how, at what time, in what range you can have a total displacement zero. But how do we measure the displacement from the velocity time graph? Let me give you a quick example so you can relate that example with this question. So just imagine if you threw a ball up with some initial velocity v0. So, and in the absence of a resistance, you have studied already this scenario very well, that it would be a free fall motion. So it will take same time to reach its maximum height and then same time to move back down. So right at that position, when it will reach at that position, it will have the same speed but the opposite velocity. Okay, so what is the total displacement covered? You, like, I'm sure you know that the total displacement covered is zero. Why? Because if you look at the graph, so here we see that this is the graph of this motion, one dimensional motion, and this is the time when it reaches the maximum height. So if you see the area, this area shows us the displacement covered to move to the maximum height. Okay, so, and the same is the displacement, same is the area but with a negative value. Yes, I'm talking about this one. Okay, so this is the time when it returned to the ground. So this is the same value but negative, it shows us the negative displacement. And if you add these two, so it means that delta x is equal to 0. So I'm sure that you got a very good idea that actually the area under the velocity time graph gives us displacement. Now this is a graph, we will explore it in detail. Actually, at in what time range do you think that we will have the total displacement 0? Okay, so let's see. So for better understanding, let's approximate this graph, right? So dear students, you see that is it, this area is a positive, which shows us that the displacement is positive, right? Okay, and what about this part? In this part the velocity is 0. Okay, and yes, this is the next part of the graph. I am approximating it again. So do you see exactly at that point it should be 7.5. All right, I hope you see it exactly at this 7.5. I'm talking about exactly this point. And don't you think if I find out this area, right, it is almost equal to the area of, like, the value in magnitude equals to this value and a negative value, and it is above, obviously above the 7.5, right? So it means that the value of the time should be more than 7 seconds, right? And it should be less than 10 seconds. So the answer should be C, because this value is showing us the negative displacement and this value is showing us the positive displacement of equal amount. So the total displacement will be 0 within this range of time.